All right, hello again. If you're watching this, good for you. You're trying to make sure that you did everything the right way. So, we're skipping number 4 and we're going directly to number 5. I have aggravated my cough by talking so much and so loudly. So this scenario D, we have 60 milligrams of furosemide administered to a patient in a single IV bolus dose. At the same time the injection was administered, a continuous IV infusion of furosemide started at the rate of 10 milligrams per hour. Now, what is the total concentration in the patient 11 and a half hours after the bolus dose is given and the continuous infusion has started? You being a smart pharmacist, you look up and you find that furosemide has a 1-hour elimination half-life and a 6.2 liter volume of distribution in this patient. Maybe a previous pharmacist has already done that for you, so you don't have, that is patient specific. That is in the chart. Let's just call this Roseanne. Roseanne, that's her her specific volume and distribution. So first off, what equations are we going to use? Well, we have a concentration IV that we're trying to find, and we have a concentration loading dose that we're trying to find. So we're going to use two equations. We're going to use the concentration of a loading dose, and then we're also going to use the concentration of a continuous infusion. And I'm going to tell you right now that I am not going to write in this part of the equation. Now, why am I not writing in that part of the equation in this particular problem? Well, let me erase all this so that when I come back to it later, it's nice and clean. Well, we are not stopping the infusion. The infusion is still running. So when you put, when T is equal to T in this particular equation here, it equals 0. So this whole entire section becomes 1. So 1 multiplied times 1 times infinity times 0 is equal to the thing it's multiplying to. So if you multiply 1 by infinity, you have infinity. If you multiply 1 by 0, you have 0. 1 times 234, you have 234. So that's why we're just not going to do any of that. I'm going to make this all nice and clean. I hate leaving my formula chart all messed up. All right, so they give us the dose, which is 60 milligrams, and our loading dose. That's in our loading dose. They also give us the rate of infusion for our concentration IV, which is 10 milligrams per hour. So this drug, we have T half-life. The hour elimination half-life is 1 hour, which is going to be really convenient later. Our volume of distribution, which we don't have to calculate out, this is the patient-specific one, is 6.2 liters. How can you tell it's a patient-specific one? Because there's volume of distribution and then there's volume of distribution. Well, if you look it up in a book, it'll always be volume of distribution is liter per kilogram. And if you got through this exam pretty decently, you would have already known that. If you had trouble with this one, the way you can tell is that the units on a patient-specific one will always be just liters. On a drug-specific one, it will be liters per kilogram. But this one is a patient-specific one and not a drug-specific one. So it's just liters. All right, let us find our Ke. So we find our Ke from our T half-life. So over 2 over 1. So that's just ln of 2. So that's 693. Then we find our clearance, because we have our rate, but we need our clearance to put into our equation. Our equation is here. So have that. We have this. We have this. We just need that. So you find your clearance by using the half-life. And multiplying it by the volume of distribution. Coolio. And you find that that is 4.2966 liters an hour. Okay, so now we have all the pertinent information that we can enter everything into our equation. So I'm going to start out with the concentration loading dose. So the concentration loading dose we're going to find that's our rate of elimination, and our infusion has been running for 11.5 hours. So we're going to use T as 11.5 hours. Now our next one is going to be the concentration of the IV. So that's our rate of infusion over the clearance. How many half-lives have happened here, guys? Just throwing it out there. There have been way more than 5, so we're probably really close to our concentration steady state, and we don't really necessarily need to do this whole entire equation, but I like doing it anyway. So I'm going to. The reason I'm just doing this anyway is because it is all written out here, and it's just easier for me mentally, even though it doesn't seem like it. So I would suggest entering each section of this separately so that you don't end up messing something up with a parentheses or something. So you find that your loading dose concentration is 0.003349 milligrams per liter, and your other concentration is 2.3266 milligrams per liter. So then your total concentration is 2.3299 milligrams per liter. Not nanograms, milligrams. I keep missing. So do we necessarily have to figure out this side of the equation? We didn't. We did not need to do that because we're past 5 half-lives. We could have done the laziest thing in the world, which is just find the concentration steady state, which is 10 divided by 4.2966, which you would have found it is 2.327, which either way you could have gone, you could have done it, but with something that's worth 10 points, I just feel more confident when I'm able to write out this whole entire thing and know exactly what I'm doing. I am the master of my own world when I do that. But you could misenter something, you could misdo something, so it's a risky strategy, but you can always, if you understand the concepts, you can always double check it. So, and this is coming from somebody who was not very good at kinetics. I was not very good at kinetics when I first started. So you guys don't have to worry about it. You just need to keep running through these problems, and when you make a mistake, learn from it. So that's just my own take on this. Because I will say, watch Professor Tolman going through question number 4, because that on the Echo lectures, which he did on September 12th, that one is pretty decent. I may run through it myself just to put into my YouTube channel, but I'm not going to necessarily put it up on the Facebook page. All right, so we're done with that one. I'm going to move on to question number 6.